Hey guys, I hope you're all doing well. You should be ready to get started on your third set of notes for this unit. These notes are for assignment number 12, graphing a circle. The learning target is I can graph a circle given its equation in standard form. So we want to be able to understand the equation of a circle in order to be able to graph the circle. Recall that a circle is defined by its center and the radius. Therefore, the standard form equation of a circle is based on these two, the center and the radius. Okay, so standard form equation. When the center of a circle is at the origin, so for example right here, the center of this circle is at the origin, the standard equation is x squared plus y squared equals r squared. For any point with coordinates x, y, so for example, this point right here with coordinates x, y, on a circle with radius r, and center with coordinates 0, 0. In other words, at the origin. Okay, so notice how the equation of this circle is very, very similar to Pythagorean theorem. And that's because this circle, as for any circle, it's defined by the distance between the center and any of its points, and any of these points on the circle. And recall that the Pythagorean theorem equation helps us to find a length, okay? So, for example, right here, this x represents the distance along the x-axis. This y represents the distance along the y-axis, so that would be one leg of a right triangle, another leg of the right triangle. There's a right triangle. And the radius would be the hypotenuse. Okay? In this example right here, this length would be, we're going from 0 to x, from 0 to x. That's where the x comes from. For this example in particular, we're going from 0 to 4 because the x coordinate is 4. Okay, so this distance would be a distance of 4. The a value would be 4 if we're comparing it to Pythagorean theorem. Over here, for this leg, we're going from 0 to 4 again. No, not 4, 3. From 0 to 3. So this distance is 3. Okay. And that's how we can define the radius, the distance between the center of the circle and any point on the circle. Okay. All right, so let's look at the first example. Let's look at the first example, and then we'll go back to this other equation. Okay, so given the equation of a circle in standard form, identify the center and radius, then sketch the graph. Okay, notice how, let me zoom out a little. Okay. Notice how this equation is very simple. It's the simple equation. It's not this longer one. Right away, that tells us that the center is going to be at the origin, okay? The center is going to be at the origin. So right here, we know that the coordinates of the center are 0 and 0. 0 for x, 0 for y. Okay, that's the first step. Then the r squared the r squared, the c squared pretty much is 36. So that goes right here. And to finish solving for r, all we have to do is take the square root, right? Square root, oops, the square root eliminates the square. So the square root of 36 is 6. Okay, so here, now we know that the center is at the origin and the radius is 6 units long. So all we have to do, starting at the center, go 6 units to the right, 6 units up, 6 units to the left, 6 units down, and then if you have a compass, use your compass to connect those points and draw your circle. Okay, now if you don't have a compass, then just try your best to make a circle by connecting these points. Okay, doesn't need to look perfect. All right, so that's example number 1, when the center is at the origin. Now for example number 2, notice how this equation is longer. It's a little more complex. That tells us right away that the center is not at the origin. Let's look at this information up here. Okay, so it says, when the center of the circle is not at the origin, the standard equation is x minus h in parentheses squared plus y minus k in parentheses squared equals r squared. For any point with coordinates x and y on a circle with radius r and center at with coordinates h, k. Okay, so right here, these letters, the h and the k, are just placeholders for the coordinates of the center. Okay, this is just a general example, okay, where we're using letters as placeholders. But this circle in particular, we can see how the center, the coordinates of the center for x, it's starting at the origin, it's 1, 2, 3. The x coordinate is 3, and the y coordinate is 2. So in this case, the h is 3, the k is 2. And over here, this point with coordinates x, y, we can see that the x coordinate is 7. And the y coordinate is 5. Okay, so here, this first part of the equation, x minus h, represents this distance. We're going from h to x. In other words, from 3 to 7. We're going from 3 to 7. That means that we are traveling 1, 2, 3, 4 units. This distance is 4. Okay, it's the same thing as 7 minus 3. 7 minus 3 is 4. That's where the x minus h comes from. Over here, this x minus h, that's where it comes from. 7 minus 3 is 4. This distance is 4 units, so 4 squared would go here. All right, and then this distance along the y-axis, here we are going from 2 to 5. From 2 to 5. So that is a distance of 3 units, right? Because 5 minus 2 is 3, and that's where this y minus k comes from. Okay, that's where this y minus k comes from, right? So this distance over here is 3. So here we have 4 squared plus 3 squared equals r squared. All right, here's our right triangle. Okay, and that's where pretty much this standard form equation of a circle comes from pretty much Pythagorean theorem, the distance formula. It helps us define this distance, this length, the radius. Okay, the distance from the center of the circle to any point on the circle. All right, so now that we understand where the equation comes from, let's look at example number 2. So here, first thing that we want to do is identify the center. So notice how I'm going to compare this equation, the one that they gave us, with the general equation, okay? We have x minus 1. This 1 would be our h, okay? This 1 would be our h. H is 1, okay? Plus y minus 1. This 1 would be our k. So we know that k is also 1. Notice how the h and the k give us the center, okay? The h and the k give us the center. So here the h would be the x coordinate of the center, and the k would be the y coordinate of the center. So we know that the coordinates of the center are 1, 1, okay? 1 to the right, 1 up. There is the center of the circle. Now the r squared would be this number right here, 25. So 25 is r squared. Now r, we want to finish solving for r. So to solve for r, we're going to take the square root of both sides, because the square root eliminates the square. The square root of 25 is 5. So now we know that the radius is 5 units. Okay, so now to finish graphing the circle, starting at the center, we're going to move 5 units to the right. 1, 2, 3, 4, 5. 5 units up. 1, 2, 3, 4, 5. 5 units left. 1, 2, 3, 4, 5. 5 units down. 1, 2, 3, 4, 5. And then if you have a protractor, a compass, not a protractor, a compass, you use your compass to connect these points. If you don't have a compass, just try your best to make a circle by connecting these 4 points. Okay, and that's it. This is example number 2. Again, when you see this longer equation that looks like this, you know that the origin is not, the center is not at the origin, okay? So there's a third example on the back side. You have a third example over here. So I want to be showing the general equation back there to help us with this third example. So the first thing that we want to do is identify the center, okay? Identify the center, and we know that the center is, okay, we know that the center is the h and the k give us the center, okay? In this case, we can clearly see that the h is 2. So that's the x-coordinate of the center. And the k, you're going to be tempted to think that the k is 1, but notice how here this has to be y minus k, but in this example we have y plus 1, okay? This should be y minus something. And the reason why this became a positive is because we have, it was a minus a negative, okay? So remember how when we minus a negative, it becomes positive or it becomes an addition. So for example, y minus -1 becomes y plus 1. That's pretty much what happened here, okay? This y plus 1 is also y minus -1, okay? Therefore, this, your k should be -1. The y coordinate of the center is -1. Okay, now that can be a little tricky, okay? So just be very careful. Anytime you see a plus, change it to minus a negative, okay? Because it should be y minus a number. All right. Okay, now let's identify the r squared. So the r squared would be this 24. Okay, and we want to solve for r. So that means that we are going to take the square root to eliminate the square. So r is the square root. R equals the square root of 24. So grab your calculator. Square root of 24 is approximately 4.9 units. Approximately 4.9 units. Okay, so now we know our radius. Okay, so we're ready to graph the circle. Let's start with the center with coordinates 2 and -1. So that means 2 to the right, 1 down. There's the center. Then the radius, that is 4.9. So we're going to move 4.9 units to the right. So that's almost 5. 1, 2, 3, 4, almost 5. So somewhere right there. 1, and then the same thing to the going up. 1, 2, 3, 4, almost 5. To the left, 1, 2, 3, 4, and then almost 5. 1, 2, 3, 4, almost 5 down. Then you grab your compass, if you have one, and you graph your circle. You connect those points to graph your circle. If you don't have one, try your best to sketch a nice looking circle by connecting those 4 points. And that's it, we're done. Graphing a circle on the coordinate plane using the standard form equation. All right, guys, you are ready to get started on assignment number 12. Have a nice day, and I will see you all soon. Bye.